Hello.
How are you doing tonight?
Pretty good. How about you?
Good. Boy, just don't
Uh,
give me any of those ridiculously hard geometry problems tonight.
yeah,
Crazy last week. I actually
I
looked
know.
looked at both of those the next day, and I solved the second one. I was overlooking a very simple two equations and two unknown problems. But the first one, the best I could do was to get it down to six unknowns and six equations, and I didn't feel like spending an hour solving that.
Yeah,
So,
yeah. No, it was hard.
anyway,
Oh,
what do we have
okay.
tonight?
Um, I'm gonna send you the link again.
Now, if your teacher gives you review material on paper, you can always
Yeah.
take a picture with your cell phone and send that to my email, and we can pull it up also.
Okay.
So, what's your username again?
Brazier TH.
And England what?
England TB.
TB?
Yeah.
Tom Brazier. Okay.
Yeah.
Why England? Just out of curiosity?
Um, we're actually English, our family, and
Oh,
yeah.
I lived in England for 3 years when I was a kid.
Oh, really?
My dad was in the military, and from ages 3 to 6, I lived in England.
Wow.
I came back to the United States with a very thick British accent.
Wow.
Yeah, small world.
Yeah.
Okay, so where do I want to go here?
So let's see. Okay, so click on the X for the welcome part. And then go, I think, wait, try the link again, actually. It should work.
Oh, now click on the link
Yeah.
once I've logged in. Yeah, that's right. That's what happened last time. Okay, cool. Um, okay. It's nice to know that they challenge you at Colorado Academy.
Yeah.
FD is the diameter, and they want as many measurements, angles, and arc angles as you can. I'm going to draw this one just so I can identify stuff. It's not that hard to draw. Let's see, we need a diameter running through there. And then we need a tangent line, or rather, let's see, what am I missing? I'm missing this one right here. Is that it, I think?
Yeah, it looks about right.
This is 48. And this is 32. And this is 16. And this is I. And okay. So help me here. What can you name here?
Um, so angle, the little right by the T, I guess, would be 48 minus 32, divided by 2, or?
You talking which angle? Can you do? You talking
It's,
an arc length?
no, it's on the inside of the circle.
You're
Point
talking
G.
EFD?
E, F, D. No, I was talking E, G, D.
E GD. Okay, so you're talking angle 1 here.
Yeah.
And we know that angle 1 is what? 1
So
half.
40, yeah, 1/2.
Yeah, 1/2
48
minus 32.
Plus. Whenever it's
Oh,
intersecting inside the circle, it's plus. And
okay, right.
you would have discovered that very quickly, because if you subtracted them, you would have gotten an angle of 8 degrees. And
Okay.
always worth checking just to make sure that it's ballpark correct. So this would be 40, which makes this 40. Okay. How about this angle 2?
Let's see. That angle would be, let's see. That'd be 48 minus,
Actually, all that is 2 chords intersecting on the circumference of the circle.
wait, is it 48 divided by 2?
Yes. So that's
Okay.
24 degrees.
Yeah.
Okay. What is this angle 3?
Angle 3 would be 32 divided by 2.
16. How about this arc length, FI?
FI.
Yeah, what can we say about FI? We know this angle, and we know this arc length. Excuse me. So we should be able to figure out this arc length here.
Is it 48 minus 16?
Well, it's actually this angle, the 16-degree angle.
Yeah.
Which, that's H. That's point H, excuse me. Has to equal what? 16 degrees has to equal, it's a function of this arc and arc FI.
Okay.
So it's 1/2. They're all 1/2. And it would be the bigger arc minus, here's where you subtract them. Because they're intersecting outside the circle. The 16-degree angle is made by an intersection of 2 chords outside the circle. So it's equal to 1/2 of 48 minus this. So we can solve this algebraic equation. We got 32 equals 48 minus FI. Take the FI to the other side, bring the 32 to the right, 16 degrees. So this I can label 16 degrees. How about this angle 4 right here?
Let's see. So that would be 1/2 of 16, so 8.
Okay. And let's see, these two angles together are 24, which means these two arcs should be 48. They are. Well, let's see, what are we missing here? A lot. We don't have any tangent lines. What's this angle 5 right here?
Let's see.
I'm going to turn my camera off.
140.
Okay. That's 140. This is 140. We probably need the measurement of each arc. In other words, we need CE, we need ID.
Right.
Okay, how else can we get ID?
ID would, well, let's see. I don't know. Aren't we missing a piece or something that?
Well, I definitely can see that we can write two equations and two unknowns. Whether we can do this an easier way or not, I'm not sure. But we can definitely, if we look at these two vertical angles here,
Yeah.
then we can say that 140 equals 1/2 of CE plus DI, correct? No, plus DIF.
Okay. But then we need to. Oh, okay.
We also know that CE plus DIF equal the remaining, let's see, we've got 32, we've got 80, so they have to equal 280.
Okay.
Between those two equations, we should be able to solve for CE and DIF. Once we get DIF, we can solve for DI. Boy, I hope these are two independent equations. I'm wondering if they actually are. No, they're not. Notice that if I multiply the top equation by 2, I get the second equation. So that's not going to allow me to solve for anything. You think about this for a little bit more here. That's 32 DI. What cuts out that besides this? In other words, one of the equations has to be 140 is equal to 1/2 of CE plus DIF. Find as many measurements, angles, and arc angles as you can. Okay. I'm trying to find stuff that would intercept arcs that we're interested in. I can't find anything that intercepts that arc except those two chords there.
Yeah.
As far as CE goes. As far as DI goes, DIF is intercepted, but that's it. fact that this is a diameter, we haven't used that information yet. Ah! There's always a little trick to these puzzles that if you don't see it, you feel like an imbecile. At least I do. What's the measurement of DIF based on the fact that this is a diameter?
DIF.
Yeah, from here all the way to there, to F.
I mean, we only know.
That's 180 degrees.
Oh.
Because the diameter bisects the circle. So it's 180 degrees from F to D, which means from I to D has to be 164 degrees. And it's got to be 180 degrees from D going this route, which means this has got to be 100 degrees. And let's see if our equation is correct. CE plus DIF is 280. Half of 280 is 140. But the thing that finally struck me into seeing this was the fact that we had not used the fact that we had a diameter here. In any of our calculations, we did not use that fact. And that gives you a lot of information. It means the arc length is 180 on this side and it's 180 on the other side.
Yeah.
So, did we fully solve it? I think we did.
Yeah, that's all.
We've got this angle right here, but that's clearly 156. Yeah, I think that's fully solved. All right. Thank goodness. I was going to feel terrible if I went 0 for 3.
It's fine as long as we get like most of them.
Yeah, no, they call these puzzles for a reason.
Yeah.
They're a little bit like a Rubik's Cube. Yeah, let's see if I don't have to draw this one here. Find as many of the same thing as you can if CJ is tangent to circle A at E. All right. Only thing.
So that means we know that two of the angles are 90.
We do. So that's 90 and that's 90.
Right.
That's 32. So shall we draw this so we can label it? It's about the only way to do it, I think. Part of that problem last week, part of the problem was how to solve 6 equations and 6 unknowns and how to label them. Remember I mentioned that it was hard to label them by a 3-letter name. So when I spent more time doing it, I labeled them with numbers. And then I realized it was hard to solve 6 equations when the variables are numbers, so I went back and labeled them with letters, A through F. Then I could actually set it up as 6 equations and 6 unknowns pretty easily. So there is a certain amount of technique involved here in how to label these angles. I hate labeling them with 3 letters. Just doesn't seem helpful. What's this? Oh, these are parallel.
Yeah.
Also, would just soon they not use the letter I in these things? Why do we have point K? What possible use could point K be?
I don't know. I think that it might just be like a because when you draw these things in the program he uses, it will just plot a point wherever you click the mouse.
Ah, okay.
So I think that he might have drawn from E to K and then just leaves a point at K.
Okay, so we know this is 90 and this is 90.
Yep.
Do we know this angle here? Have this triangle here, this right triangle. That's the third angle in that right triangle.
Oh, right. Oh, I didn't see the 32. So that's 180 minus 90 minus 32.
Another way to look at right triangles is the two acute angles have to be complementary. They just add to 90. Just
Okay.
make the calculations a little easier, not having to use 180 and you can use 90 instead. Okay, so that's 58. This other angle here is 122.
Yeah.
What is this arc length from H to E?
H to E. That's 58.
And the arc length from E to F?
E to F is 122.
This is 58 here. This is 122. This is actually a pretty easy one. What's the arc length from, maybe I spoke too soon here. Let's see. We know because these two lines are parallel, what is angle 3 here? Not because they're parallel, but I have this program that the moment you touch a line, it erases the whole line, plus a bunch of others. All right, this angle down here, what's that?
That is, we need one more angle.
29. Only because we've got two chords that intercept this 58-degree arc.
Okay.
See that?
Yeah.
The EG and HG intercept the arc EH. And since we knew EH was 58, then this has to be half of 58. So that's 29. The third angle of this triangle, that's totals 151, so this must be 29. Actually, we could have told that because we have a radius there and we have a radius there. So that has to be an isosceles triangle.
Yeah. Oh, yeah, I didn't see that.
Let's see, what else can we tell here? We've got, that totals 180. We know it totals 180 from H all the way to F, but we need some more measurements here. Okay, we've got this 90-degree angle. That means that what is the measurement from E around to G, also because that's the diameter. So from E, H, I, G, what is that arc length?
EHIG. So that's 122 plus 58.
Right. So it's 122 for the for the HIG is 122.
Right.
And because these two lines are parallel, the diameter and this line here, and this angle is 29 degrees, what other angle is 29 degrees? would be this one right here.
Oh.
Because you have a parallel line, the diameter, you have a parallel line here, and there's the transversal, so there's 29 degrees there. This has to be 29 degrees also, if these
Okay.
lines are parallel.
Yeah.
Okay, so that's the 29, that's the 29. What's that make this arc length here?
That would be arc length IG, you mean?
IG, yeah. So
That
that
would be
twice 29,
oh, okay.
because we have these chords that intersect on the circumference. So this
Right.
arc length has to be double that angle. And finally, that allows me to figure out what HI is, because the whole thing is 122. So HI must be 64. Let's erase the 122. And now we know FG, because HIGF has to be 180, right? Because
Yeah.
there's a diameter. HF is a diameter. So what's that? 122, 58. So we've solved all the outside arc measurements, and I think we've solved all the angles.
Yeah, I think so too.
Okay. These are good in that they require you to draw on 3 or 4 different theorems in order to solve them.
Yeah.
I think I'm going to have to draw this also. Wow. This is angle 5x plus 16. This is angle x plus 20. And this is tangent. And this is 22 degrees, and that's C, and that's E, and this is O, N, M. These hash marks mean they're the same, huh? You don't see that very often. M-O-N is the same as N-M.
Yeah.
Well, let's first solve for x. That's pretty easy to do. If those two angles, if this one's x plus 20 and this one's 5x plus 16, what can you say about those two angles?
Well, I know that's equal to 180.
Right, because that's the diameter. Well, because it's a straight line. So we have 6x plus 36 equals 180, correct?
Yeah.
6x equals 144, x equals 24. So if x equals 24, then this angle is 44. And this angle is 120 plus 16, 136. Makes this arc NM equal to what?
NM is equal to ON.
But what is the measurement of n?
44.
Okay. And this is 44 because they told us it was. What's this angle 1?
That would be, which one's 1?
This one?
Oh. That would be 22.
Okay. This angle here is obviously 22.
Yeah.
This arc is 136. So we see we got the right half of the circle done. And the left half, what are we missing? We're missing these arc lengths. We know that LEON is 180.
Yeah.
Which means LEO is 136. So it's 136. So how do we get EL and EO, which are the only two things missing?
EL.
Do we have any other angles that cut that thing out? Well, we have this 22-degree angle. What can I say about EL and EO? 22 degrees is equal to what?
2 times EL.
1/2
Or 1/2 of EL, I mean, yeah.
of EL plus or minus EO?
Minus.
Because it's intersecting outside the circle.
Yeah.
Okay. And what else do we know about EL and EO? Wonder, what do they add to? What does EL plus EO equal?
They equal 136.
Okay. Now, is this going to be the same thing as I had before? In other words, are these two things that are dependent on one another? I don't think so. I think we can solve this one. Let's see. If I make that 44 equals EL minus EO, then EL is equal to 136 minus EO. Now let's substitute. We got 44 equals EL, which is 136 minus EO minus another EO. EIO, we got 2 EOs on the left side equals 92 on the right side. EO is equal to 46. So this one's 46, means this one's got to be 90, because they totaled 136.
Okay.
Now we've got the whole thing. Now, does that make sense? Let's see, yeah, because 22 needs to be half of 90 minus 46, and it is. Okay, the last question there, and the figure is EC parallel to LN. EC is this tangent line, and LN is the diameter of the circle. if I draw them separately so that you can kind of see them, here's EC. Here's LN. And we have a transversal that's 22 degrees there and 22 degrees there. Does that ensure that these two lines are parallel?
Yeah.
Yes, it does. In other words, the corollary goes both ways. If you have two parallel lines with a transversal, this angle is equal to that angle, and the opposite, or rather the corollary of that, is if you have two lines and this angle is equal to that angle, then those two lines are parallel.
Okay.
So
two transversal angles.
Yeah, the basic model is this, and this is worth going over actually, especially if you're ever going to take the ACT test. This is big. Here's my two parallel lines with a transversal. Now in geometry they go to a great deal of trouble to label these 8 angles and give you names for them and everything else. Well, to me, you only create 2 angles, A and B, that are supplementary to one another. Every other angle that's created is one of these 2. So
yeah.
All the little angles are B, all the big angles are A. So knowing that is very important. And that's why in our model, what we had was 22 degrees equals 22 degrees. In other words, we had angle B given to us. And since they are equal to one another, then these two lines have to be parallel.
Okay.
Okay, got any more?
Yeah.
Okay.
I've got one more. We had a lot tonight actually, so it was a good night to have a lot, I guess.
Let's see, how do I guess I got to close that out. Oops.
Yeah, that's fine. And then just click on the link I sent you.
It's telling me I've timed out. Let's see if that works. No. Let's see, I need that England TB. England TB. Now I click on the link. Okay. Trapezoids. What's the formula for the area of a trapezoid? Might think of it as a rectangle. What's the formula for the area of a rectangle? Base times height?
Okay. All right, yeah.
A trapezoid is the average base times the height.
Okay.
What's the average base? Base 1 plus base 2 divided by 2. So the area of the first trapezoid is what? The bases are always the sides that are parallel to one another.
Right. So 21 plus 9 divided by 2.
Okay, so that's 15. And what's the height?
The height is...
They don't give it to us. They're going to make us work for it, of course. Every other geometry student, they're going to give you that height, but not Colorado Academy. So
Yeah.
AD is equal to BC, and it's equal to 10. So that side is 10. And it's equal to BC, which is 10. Which means if I drop a vertical from right there, those two measurements have to be what? Now hold on a moment. This 21 is D to C, correct?
Yeah.
All right. I'm going to have to draw this, I can see also, just to figure it out. This is an isosceles trapezoid, and that's going to help, I think. The fact that those two are equal to one another. And it's 10. This is 21. This is still 9. What does this measurement here have to be? It's the same on both.
That has to be... Well, 21 minus 9 divided by...
That's correct.
Yeah.
21 minus 9 divided by 2, because there's two ends. So now we can solve for the height. What kind of triangle is this? Do you recognize a 6? One side is a 6, the hypotenuse is a 10, it's a right triangle. This is a 3, 4, 5 right triangle, meaning that's 8. Now, if I didn't recognize that, I could have solved for it. Let's go through that. Go through the Pythagorean solution. If I'm trying to solve for h, what's h equal to?
H is equal to...
If we apply the Pythagorean theorem to this, we've got 10 squared equals h squared plus 6 squared. So h squared is equal to 10 squared minus 6 squared. H must be the square root of that.
Okay.
That's equal to the square root of 64, which is 8. It's worth knowing how to use the Pythagorean theorem to solve right triangles because you have to do it so much. Let's review it a little bit. I mean, I know that if you know the Pythagorean theorem, in other words, if you know that c squared equals a squared plus b squared, you can always figure out how to solve for one of these. But rather than have to go through it each time, let's just memorize it. That means c is always the square root. In other words, if you're solving for a hypotenuse, it's always the square root of the sum of the squares of the other two sides. If you're solving for one of the sides, it's still the square root. They're all the square root of something, but it's always the square root of the hypotenuse squared minus the square of the other side. Likewise, b is the square root of the hypotenuse squared minus a squared. So if you can memorize that and that, because the second two are basically the same, whenever you're solving for one of the other sides, you're going to use this equation. And whenever you're solving for the hypotenuse, you're going to use this equation. So it's kind of worth memorizing these just because you have to do it so frequently.
Okay.
Let me give you a couple of drills here. What's this hypotenuse?
So it's 5 squared plus 3 squared equals the hypotenuse?
No. When you're solving for one of these sides, always start out with square root of. In other words,
Okay.
the hypotenuse is the square root of something, and side A is the square root of something. So it's the square root of, in this case, the square root of 3 squared plus 5 squared. So that would be the square root of 34. Okay. Solve for this side here.
So, let's see.
And I'll leave that up.
So that would be the square root of 16 minus
16 squared.
16 squared, yeah. Minus 6 or 5 squared.
Right. And whatever that number is. In other words, it's always the square root of something, and the something is always stuff squared. It's never just 16. It's always going to be a 16 squared, a 5 squared. Everything inside the radical is always squared. So being able to use either of those at will is pretty handy because you have to do it so frequently in order to do geometry. So the area of this trapezoid was 1/2 of the average base, which was, 1/2 of the sum of the bases times the height. So 15 times 8, which is 120 for that first trapezoid. Okay. Oh, good. I don't have to redraw anything. I just have to relabel. That's now 5 for our second one. And yeah, still it's still a isosceles trapezoid because AD equals BC equals 13. We don't have that anymore. So I think that's all we have. So what's this dimension right here?
So that has to be then
Square root.
Square root of 13 squared minus 5 squared.
Good. Which is the square root of 169 minus 25, which is square root of 144, which is 12. So that's 12, and that's 12. And in fact, that's another Pythagorean right triangle. It's the next smallest one after the 3, 4, 5 is the 5, 12, 13. So what's the area of this trapezoid?
So the area of this one is then, wait, so it's the base times, or
Average
what was it?
base. It's the average base. What's the average base here?
So it was 21 plus 9, or was it minus 9?
Well, what's
Wait,
our
what was that? You wrote it out at the beginning.
what I didn't hear what you just said.
It was something you wrote out at the beginning.
Yeah,
It was
base 1 plus base 2 divided by 2. There's your average base.
Okay, right, yeah.
Times height. Times vertical height, not slant height. So what's base 1 here?
So then base 1, so 21
Where
plus...
are you getting 21?
Oh, on the worksheet.
We're doing number B.
Oh, right. Sorry, my bad.
It's not 21. It's going to be 12 plus 9 plus 12.
Yeah.
That'd be 33.
So, yeah, 33 plus 9 divided by 2.
Times the height of 5.
Right.
Which is 21 times 5, 105. Okay. You want to do another trapezoid problem, or should we do a kite problem?
Let's do a kite.
We probably just have time for maybe one.
Okay.
Whereas once you've done one trapezoid, I think you've done them all.
Yeah.
No, this is a little different. This is not an isosceles trapezoid. However, they give us the length of AD and they give us the length of BC, so we can figure out, knowing that that's 10, we can figure out these two sides and thus figure out both bases. So that's another Pythagorean, in other words, that's another right triangle problem, 2 of them.
Okay.
So let's look at the kite. The kite, this side is equal to this side. In other words, TE is equal to TI, and EK is equal to IK.
Okay.
Using dissections, rotations, or some other strategy, rearrange it to make a rectangle.
Right.
Okay.
These are kind of odd.
They are kind of odd. Let's look at this one over here because they're helping us a little bit by drawing in the diagonals. So I don't have any parallel sides. What they want us to do here is to take some of these quadrants and move them. What if I took this quadrant right here and flipped it so that this side here was even with this side here? That looks like it'll make a little rectangle. And then
I think I know how to do this.
Yeah, and then I can do the same thing up here with this. I can actually, if I just take this little portion here and rotate it 180 degrees, it fits right on here, and then I have a rectangle like that. Right, I do exactly the same thing with this, rotate it all the way around. Now I have a rectangle there, and in fact I have one big rectangle.
Yeah, and then you just add it on. All right.
Yeah.
Yeah.
What measurements would you need to know to find the area of a kite? What's the formula for the area of this kite?
Is it the same as the trapezoid, or?
No, it has to do with these diagonals. Think about what we just did for a second, and if we did fold this over into two rectangles, what would the measurements of that rectangle be? The length of it would be this diagonal, right?
Right. Yeah.
And the width of it would be this diagonal, half of this.
Okay.
So the formula for the area of a kite has to be 1/2 of diagonal 1 times diagonal 2. Now, another way to kind of see that is, in other words, it's easy enough to know that it's one diagonal times the other diagonal, but it's not always easy to know that it's half. In other words, you may be taking a test and you're not sure if it's half or is it the whole thing. Well, notice that if I were to draw a rectangle about those diagonals, so that those diagonals represent the base and height of my rectangle, well, clearly the area of the rectangle is the base times the height, diagonal 1 times diagonal 2. And the area of the kite is a lot smaller than that. And in fact, it's half. In other words, this side of this kite divides this rectangle into 2, divides that into 2, divides that into 2, and this into 2. So the kite occupies exactly half of the space of that rectangle.
Okay.
Okay? So
Yeah.
I think we've covered the essence of question 2.
Yeah.
We know how to turn that into a full rectangle, and we know why the area is half. Notice that it's half because we're only using half of this diagonal when we turn it into a rectangle. When we turn it into a long rectangle, the width is only half of this diagonal.
Okay. Yeah.
Well, it's 9 o'clock. Why don't we call it a session? I don't want to press my luck. I knew how to do everything tonight.
Yeah.
I'm just kidding, actually, but no, that should be helpful to you.
Yeah, definitely. Thank you.
Okay. All right.
And my mom wants to know, how do we pay for the online sessions?
You can do it 2 ways. Do you have a PayPal account? Does she have a PayPal account?
I don't think so.
Okay. She's certainly welcome to drop a check in the mail to me. Let me give you my address. I'll just write it out here. I only live about 5 blocks away.
Oh, wow.
Yeah. So it's David Cowan. She can make the check to David Cowan. And that's Littleton 80127. And if she does have a PayPal or wants to start one, they're actually pretty handy things to have. Have her make the payment to my email address, which is my account name at PayPal. So she can either pay that way through PayPal or just send me a check for this. And I can send out an invoice, and I'm happy to, but the total would be 14 from our last online session, 28 for today, so 42 bucks at the moment.
Okay.
Okay?
Sounds good.
And all right. Next Wednesday online?
Yeah, let's plan for online, and then
Okay.
I don't know,
If you ever want to
like
change.
online, it's
Yeah,
convenient.
I like it too, actually, even though you do only live 5 blocks away. It's nice to not have to, interrupt your family and stuff there. And I think it works just as well. And in fact, maybe better because you do get this recording. Did you have a chance to look at the last recording at all?
Yeah, I did.
I will post this to exactly the same page. It won't be a new link. So as long as you save that last link, you'll always be able to see these recordings.
Okay.
Okay? It does take 3 or 4 hours to process it, though, so it won't be up until tomorrow morning, most likely.
Yeah, that's fine.
All right.
And then, yeah, next week I was thinking I'll let you know, I might want to have it in person just because we have finals the next week.
That's fine. No problem. No problem at all.
Depending on like if we have a review sheet or something, I might
Yeah.
want it in.
Yep. No, I agree. Totally.
Okay.
Just let me know. And I will talk to you next Wednesday.
Okay, sounds good. Thank
All
you.
right, Thomas. Bye-bye.